Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. In our previous session, we have written a program to communicate our RTU with the master terminal unit, that is computer. And here we can find our previously written program in which we are transmitting a string to the microcontroller, and microcontroller is sending back the string to the master terminal unit, that is the USR terminal of microC compiler. Let's check our program once again. For this, we'll go to the tools. We'll go to the USR terminal, and here we will select COM port 3. Now we'll connect the COM port 3, and now we'll send a string with the delimiter sign, that is %sign, and now we'll press the send button. Here we can find we are receiving the same string as we have transmitted to the microcontroller. And now we'll write a program to send the data on port B of the microcontroller. As we know that we have connected 8 LEDs with port B of the microcontroller. So we'll send a number that is 0 to 255 to print the data on 8 LEDs. And now we'll implement our first command that we have devised to write the data on 8 LEDs. And here we can find our own devised command to print the data on 8 LEDs, that is LED, and the data that is 000 to 255, and the delimiter that is %sign. And from the schematic we can check that we have connected 8 LEDs with port B of the microcontroller. And now we'll use this protocol to print the data on 8 LEDs. And now we will send the same command to the microcontroller, and we'll go to the tools, USR terminal, and we'll connect the COM port 3. And here we'll write the command that is LED 000 and the %sign as delimiter. Now we'll send the string, and here we can see we have received the same string from the microcontroller. Now we'll modify our program to take a decision on this command. As we have to print the data on 8 LEDs at port B, so we'll define a flag that is LED flag, and here we'll write the flag assignments. And here we will define a flag that is LED flag. So here we will write that is bit LED flag. And now we'll use this flag to write the data on port B. And here in serial read routine, we will set the flag that is LED flag if the first 3 characters of the string will be LED. So here we will write, and here we will use a prototype that is string comparison, and we'll define an integer to compare the result of 2 strings. And here we will define an integer to compare the result of 2 strings, that is unsigned integer, that is test string, equals to 0. We will use this integer that is test string to compare the result of 2 strings. So we'll copy this variable from here, Control C, and we'll paste the variable here, that is Control V, equals to strncmp string comparison, and we'll compare the first 3 letters of the receive string with the predefined letters, that is LED. So we will copy this variable from here, that is receive string, Control C, and we'll paste it here, Control V, and we'll compare the first 3 characters of the receive string with LED, that is LED, comma 3. It means that we want to compare the first 3 letters of the receive string with the letters, that is LED, and here is the length of the string, that is 3. And now we will go to the system libraries, and here we will select string library. If the first 3 letters of the receive string will be compared with the letters, that is LED, then the value of the integer, that is test string, will be 0. So here we will write that is if test string equals to 0, then our program will come into this if condition. And here we will set the flag that is LED flag. So here we will write that is LED FLG equals to 1, and if the first 3 characters of the receive string will not match the characters, that is LED, then the value of the integer, that is test LED, will not be 0. And now we'll define a variable to separate the data from this command, that is LED000. So we'll define a string variable of length 3 characters, and here we will define the variable, that is data string, and the length of this variable will be 3 characters. And now we will write the LED print routine. So here we will call another subroutine, that is LED print routine. And we will write the LED print routine before main program. And here we will write, that is void and we will write the LED print routine between these two braces. So here we will check the status of the LED flag, and we'll check if the LED flag will be 1, and we'll write, that is if LED flag equals to 1, then our program will come into this if condition. And here we'll use a prototype, that is string copy, and here we will write a string copy, and here we will use a variable, that is data string. So we'll copy this variable from here, Control C, and we'll paste the variable here, Control V. And now we'll copy 3 characters from the receive string, that is 000 to the data reg, and we know that data starts after 3 characters in receive string. So here we will write, that is rec a string plus 3 comma 3. This prototype will copy 3 characters from the receive string to the data string after LED characters. And now we'll convert the data string into the number. For this we'll go to the help, and here we'll go for C standard library, and here we can find a library function, that is A2I, and here we can find the description of the prototype, that is A2I, that is a convert a string into a number. Now we will use this prototype in our program, and we'll define an integer to convert this string into a number. So here we'll define an integer, that is data register, that is unsigned integer data reg equals to 0, and we'll use this variable to convert the string into a number. So we'll copy this variable from here, Control C, and here we will use this variable, Control V, equals to A2I, that is data string, and here in system libraries we'll select the standard library, and now we'll print the number, that is data reg to LED port. So here we will write, that is LED port equals to data reg, and after sending the data reg to LED port we'll clear the flag, that is LED flag. So here we will write, that is LED flag equals to 0, and now we'll compile and download our program to the RTU, and we'll observe the result of our program on our embedded system. Okay, right. And now we'll send the command to the LED port from the USR terminal of microC. And now we'll send the command, that is LED000. We'll replace the data from 000 to 001. So here we will write 001. And now we'll send the command. Okay, send. And here we can check the number 1 is displayed on LED port. Now we'll send another number, and we'll change the data, that is 2. And now we'll send the command once again, and here we can check number 2 is displayed on LED port. Now we'll try another data, that is 127. OK, send. Here we can check the number 127 is displayed on LED port. And now we'll clear the data and we'll send the number that is 000 to LED port. OK, send. So here we have implemented our first command, that is LED 000, that is LED and the data from 0 to 255. LED is the command to print the data on 8 LEDs, and the character 000 represents the number from 0 to 255. And now I'll write a program to switch on and switch off the buzzer from the master terminal unit. To control the status of the buzzer, we'll define another flag, that is buzzer flag. So here we will write buzzer flag, and we'll initialize both the flag to 0 in our main program. So here we will write that is LED flag equals to 0 and buzzer flag equals to 0. And now we'll use the buzzer flag in our serial read routine. And here we'll copy these 3 lines from our previously written program, that is Control C. And we'll paste these lines here in our serial read routine, that is Control V. And we'll modify the prototype to control the status of the buzzer. And here we will write that is buzz. If the first 3 characters of the received string will be compared with BUZ, then the integer, that is test string, will be 0. So here we will set the buzz flag. So we'll replace the LED flag with buzz flag. And here we will write that is BUZ. And now we'll use this buzzer flag in buzzer control subroutine to control the status of the buzzer. And here we will write that is buzzer routine. And we'll write the buzzer routine before main program. So here we will write that is buzzer control routine, and here we will write that is void and we'll write the buzzer routine between these 2 braces. And here we will check if the buzzer flag is set. So we'll write that is if buzzer flag will be 1, then our program will come into this if condition. And here we will check the 4th character as data. If the value of this character will be 0, then the buzzer will be off. And if the value of this character will be 1, then buzzer will be on. And here we will use the string comparison prototype once again. So we'll copy this line from the serial read routine, Control C, and we'll paste the prototype here, that is Control V. And we'll modify this command to control the status of the buzzer. So here we will write if the received string plus 3 characters will be compared with the number 0 and the length of the string is 1. If the 4th character of the received string will be 0, then we will write that is if test string equals to 0, then our program will come into this if condition. And here we will switch off the buzzer, and here we can check we have defined the port C not as buzzer. So I'll copy this assignment from here and we'll paste it here. Control V will be 0. If the 4th character of the received string will not be 0, then we'll check if the 4th character of the received string will be 1. And here we will write that is Control C, Control V, and here we'll compare the 4th character of the received string with 1. And here we will write that is if test string equals to 0, then our program will come into this if condition. And here we will write that is buzzer equals to 1, Control C, and we'll paste it here, Control V, and here we'll set the value of port C naught as 1. After implementing these commands, we will clear the status of the buzzer flag. So here we will write that is buzz flag equals to 0. And now we'll compile our program and we'll observe the result of our program on our prototype. And now we'll send the buzzer control command from the USR terminal of microC. OK, connect. And now we'll change the command, that is BUZ1. It means buzzer will be on. And now we'll send the command. OK, buzzer is on. And now we'll switch off the buzzer. We have implemented our second command to control the status of the buzzer, that is BUZ 0 or 1, and the delimiter, that is %sign.